Hi, in this video we're going to have a look at Pure Math 3 past paper from February-March 2022 series. Let's have a look at the first question, and that's inequality with the modulus sign. And for that we have a very standard procedure where we have to square both sides and solve the resulting quadratic inequality. So square the left side and don't forget to square the 3 on the right side. Now expand the brackets. And multiply out 9 on the right side of the inequality. And now I'm going to collect all the terms on the right side of the inequality. So I will get 5x squared, then plus 24x plus 27 less than 0. Now, how do we solve this inequality? So first of all, I'm going to draw a quick sketch. So it's x-axis and the quadratic function opens up. Now we're looking for all the values of x for which the graph is below x-axis. So it's going to be in between x1 and x2. Now, how do we determine those x1 and x2? That's basically where the quadratic equals to 0. So we'll have to solve 5x squared plus 24x plus 27 equals to 0. And I will use the quadratic formula, minus b plus or minus square root of b squared minus 4ac. Then over 2a, which is 10. Okay, now simplify that a little bit. So when I take the plus sign in the formula, I will get x1 equals to negative 3, and then x2 equals to minus 1.8. And now my answer is going to be x is in between negative 3 and negative 1.8. Now question 2 is about the Argand diagram, and the first inequality represents the circle. So modulus z minus z1 equals to r. That's going to be a circle. Center in z1 and a radius r. And the second inequality with the argument z minus z1 is going to be a half line which starts from z1 at the angle theta. Okay, now before we start drawing, let's write the first inequality in this form. So we're going to have z minus 2 plus 3i smaller or equal than 2. Okay, now we can start drawing the diagram. Y-axis is going to be imaginary part of the number, and the real part is going to be the x-axis. So we'll have to find minus 2 plus 3i on the diagram somewhere here, and we'll draw a circle with the radius 2. So it's going to be something similar to that. Now let's indicate the center, minus 2. This is 3. Okay, and let's have a look at the second one. So argument z is less or equal than 3 pi over 4. That means that's a half line that starts from the origin. And 3 pi over 4 is going to be 135 degrees. So that means the line goes this way. Now let's shade the region. So the first inequality says the modulus is less or equal than 2. So that means we need all the points that are inside the circle. And the second inequality says that the angle should be less or equal than 3 pi over 4. So that means we have everything inside the circle, and then the angle is less than 135 degrees. We're done with this question. Okay, question 3 is about changing the exponential relationship into linear form, and to do so, we'll have to first take the natural log of both sides. Now, on the left side, we have log of the product, and we can change it into the sum of natural logs. Now, the power is going to go in front of the log, so it's n times natural log x plus 2 natural log y equals to log c. Okay, and then I'm going to move n log x on the right side. We'll get 2 log y equals to minus n natural log x plus log c. And then finally, I'm going to divide by 2 to get minus n over 2 natural log x plus 1 over 2 log c. And now we can spot that if we make a variable change and say natural log y equals to, let's say, capital Y, and natural log x equals to capital X, we actually have a linear function which looks like y equals to minus n over 2x plus half log c. And then the gradient of this function is going to be whatever is in front of x, so that's minus n over 2. And that linear function is on our graph. So to find the gradient of this graph, we'll have to find change in y and then over change in x. So I'll do 1.21 minus 0.91, that's change in y, over change in x, which is 0.31, take away 1.06, and then I will get minus 2 over 5. Now let's move back. Since we know that the gradient is minus n over 2, and then on the other side is minus 2 over 5, we can say that minus n over 2 equals to minus 2 over 5, and then from here we can find n, which is going to be 4 over 5. Our equation of the straight line is going to be y equals to minus 0.4x plus half natural log c. Now, to find c, we can substitute any point on this line, and I will use the point 0.31, 1.21. So 1.21 equals to minus 0.4 times 0.31 plus a half natural log c. And now I'll have to rearrange this equation and get log c, which is 667 over 250. And then raise it to power, e to the power of 667 over 250 to get c equals to 14.41. Okay, and let's state this as the final answer. N equals to 0.8, and then c equals to 14.41. Question 4 is about differentiation. We have to find dy dx. But we have x in terms of some other variable theta. So we could do dy over d theta. Then because we're looking for dy over dx, we don't need d theta. So we're going to multiply by d theta over dx. And I will have to find both dy over d theta and then dx over d theta. Let's start with dx over d theta. It's going to be derivative of 1 is 0, then minus. Derivative of cosine is minus sine theta. Minus and minus will cancel out, so we got sine theta. Now for dy over d theta, derivative of cosine is minus sine, minus 1 over 4, negative sine 2 theta, and then don't forget the chain rule and multiply it by the derivative of the inside function, which is 2 theta, so times 2. Now let's simplify that, and we'll get minus sine theta plus 1 over 2 sine 2 theta. And now we're ready to find dy over dx. It's going to be minus sine theta plus a half sine 2 theta all over sine theta. Now, is it the form they are asking us to get? No, not yet. So first of all, let's get rid of sine 2 theta and rewrite it using the double angle formula, which is 2 sine theta cosine theta. And we'll get minus sine theta plus a half times 2 is 1, so it's just sine theta cos theta over sine theta. And that means sine will cancel out, and we'll get minus 1 plus cosine theta, which is again not what we're asking for. Our answer should be in terms of sine and in terms of theta over 2. So that means we can try to use the double angle formula one more time, which is cos 2 theta equals to 1 minus 2 sine squared theta. Okay, now because it's a double angle formula, we could say that cosine theta equals to 1 minus 2 sine squared theta over 2. Right, because on the left, the angle is still double of the angle on the right. And I will replace cosine theta with 1 minus 2 sine squared. So I'll get minus 1 plus 1 minus 2 sine squared theta over 2. And now all in all, I've got minus 1 plus 1, which is 0. So we've got minus 2 sine squared theta over 2. And that's exactly what they were asking us to get. Next question, it's basically simultaneous equations. Tangent alpha plus beta equals to 2, and then tangent alpha equals to 3 tangent beta. Now, first of all, I'm going to expand tangent alpha plus beta using the compound angle formula, and I will get tangent alpha plus tangent beta over 1 minus tan alpha tan beta, and that equals to 2. Next, I'm going to multiply both sides by 1 minus tan alpha tan beta to get rid of fractions. And in the next step, I will substitute tangent alpha equals to 3 tangent beta. So I will get 3 tangent beta plus tangent beta equals to 2 minus 2 tangent beta times 3 tan beta. Okay, now simplify it and I'll get 4 tangent beta equals to 2 minus 6 tangent squared. And that's almost, well, it is a quadratic equation. So let me just move everything to the left side and I'll get 6 tangent squared beta plus 4 tangent beta minus 2 equals to 0. And I will make a variable change. I will set tangent beta equals to t. So I got the equation 6t squared plus 4t minus 2 equals to 0. Now divide everything by 2 to make it a bit easier. So 3t squared plus 2t minus 1 equals to 0. Let's use the quadratic formula. T equals to minus 2 plus or minus square root of b squared 4 minus a minus is going to be plus 12 over 2a, which is 6. So it's minus 2 plus or minus square root of 16 over 6, which is minus 2 plus minus 4 over 6. And if I take the plus sign in the formula, I will get 2 over 6, which is 1 over 3. Or if I take the minus, I will get minus 1. Now substitute back. That means tangent beta equals to negative 1, or tangent beta equals to a third. Take the inverse tangent of both equations, so beta equals to negative pi over 4, or beta equals to 18.43, or I should have stated as negative 45 degrees. If we look at the range, we should be in between 0 and 180, and minus 45 is not in range. So for tangent, we can always add up 180 degrees. So beta will be 180 minus 45, that's going to be 135. So tangent alpha, minus 1 times 3 is going to be minus 3, or tangent alpha, a third times 3 is 1. So from here, alpha is going to be minus 71.56, which is again not in the range, so I'm adding 180. And I will get 108.4 degrees for alpha. And in this case, alpha is 45 degrees. That's going to be the final answer, so let's state it here. Alpha equals to 108.4. Beta equals to 135. So this is one pair. And it's the second pair where alpha equals to 45 and beta equals to 18.43 degrees. Question 6, complex numbers again, and we're looking for solution to the equation in the form x plus iy. So I'm going to say let w be x plus iy, and then w asterisk means complex conjugate, so I will have to change the sign of the imaginary part. It's going to be minus iy. And now I can substitute all of this into the equation. So I'll get x plus iy squared plus 2i times complex conjugate, which is x minus iy equals to 1. And then I will have to expand the brackets. It's going to be x squared plus 2xyi minus, because I squared is negative 1, so it's minus y squared, plus 2xi, and then plus, because again I got I times I, which is negative 1, so I got plus 2y. And let's move 1 to the left side, so I got 0 on the right. Okay, now what I'm going to do is I will combine everything with I and everything without separately. So I'll get x squared minus y squared plus 2y minus 1. So it's going to be the real part. And then for the imaginary part, I will get 2xy plus 2x times I. And that equals to 0. Because we have a real part, and we got an imaginary part, and a number equals to 0. That can happen only if the real part equals to 0 and imaginary part equals to 0. So this equation splits into two simultaneous equations, x squared minus y squared plus 2y minus 1 equals to 0, and 2xy plus 2x equals to 0. And I will start from the second equation. I will factorize and bring 2x outside. I'll get y plus 1 equals to 0. And that splits into 2x equals to 0, or y plus 1 equals to 0. That brings us to x equals to 0, or y equals to negative 1. Now, I'll have to use both cases. in the first equation. So first of all, I will substitute x equals to 0. I will get minus y squared plus 2y minus 1 equals to 0. And that can be written as y minus 1 squared is 0. So that means y equals to 1. Now, the second case, if y equals to negative 1, again substitute this into the first equation, we will get x squared minus 1 minus 2 minus 1 equals to 0. So that means x squared equals to 4, x equals to positive 2, or x equals to negative 2. Now let's have a look at what the question says. It says the real part is less or equal than 0, and the real part of our solution is x. So that means we'll keep x equals to negative 2, and we'll keep x equals to 0. And for those cases, when x equals to 0, y equals to positive 1. So that means our answer is going to be w equals to I. Now for the second case, when x equals to negative 2, y equals to minus 1. So our answer is going to be w equals to negative 2 minus I. That's the answer. Okay, question 7. Here we have to sketch a pair of graphs. And first of all, I will change secant half x to be y equals to 1 over cosine x over 2. And let's start drawing the sketch. Here's y-axis, and we need the x-axis. I will start with the first graph, y equals to minus x squared plus 4. That's going to be a quadratic function, vertex at 0, 4. It opens down and it will intersect the x-axis at points 2 and minus 2. Now, for the second graph, I'll just draw a table of values to understand better what's going on. So x and y. I will choose some key points, 0, pi over 4, pi over 2, and pi. So if I substitute these points into the calculator, I will get 1 when x equals to 0, then I get 1.08, then 1.4, and finally, if x equals to pi, I get a math error, so the value is undefined. Okay, and let's plot these points on a graph. X is 0, y equals to 1. Next we got pi over 4, 1.08, so it kind of goes up a little bit. Pi over 2, that's 1.4, keeps going up. And finally, if x equals to pi, the graph tends towards the infinity. Let's draw the vertical line to indicate that this is an asymptote. Now, we have to show that there's only one root in the interval, and we can see that by looking at the sketch and seeing that there's only one point of intersection. So let's write this as a conclusion. One point of intersection, therefore only one solution. Okay, next one. Verify by calculation that this root lies in between 1 and 2. And in order to do so, we'll have to substitute 1 and 2 into the equation and see how the inequality sign changes. So let's say x equals to 1, and I substitute it into the equation. The left side is 4 minus 1 squared, which is going to be 3. And then the right side of the equation is secant 1 over 2, which is approximately equal to 1.14. And 3 is bigger than 1.14. Now, when I substitute x equals to 2, I get 0 on the left side and secant 1 on the right side, which is approximately equal to 1.85, and this time 0 is smaller than 1.85. So now here's the logic. If x equals to 1, then the left side of the equation is bigger than the right side. If x equals to 2, then the left side is smaller than the right side. So that means that somewhere between 1 and 2, the left side should be equal to the right side. And we can write it as the conclusion. The change of the inequality sign indicates the presence of the root on the interval. Okay, next question. We'll have to use the iterative formula to determine the root correct to 2 decimal places. Okay, draw the table. Let's say we're going to have xn, and then the next value, xn plus 1. Now, according to the previous question, we have a root in between 1 and 2, so I will start with 1.5. You could choose any value in between 1 and 2. Now, substitute into the formula, and we'll get 1.6227. Now, this new value becomes xn again. Substitute it into the formula and get 1.5961. Now, this becomes the new xn, and I will basically have to continue the process. Until I get the same number correct to 2 decimal places. And that's already the case. So it's the same number correct to 2 decimal places. That means this is going to be our answer. 1.60. Just a side note, don't forget the 0 at the end because they're asking for the value correct to 2 decimal places. And writing just 1.6 would be only 1 decimal place. So 1.60 only. Next question is about the polynomial division. Let's write it down. Okay, now I'm just going to look at the highest coefficients. So I got 4x squared and 8x cubed. I will have to multiply 4x squared by 2x, so I can get 8x cubed. And when I do so, I will get 8x cubed plus 2x. Now subtract the two polynomials and I will get 4x squared, 2x minus 2x will cancel out, and plus 7. Okay, now I will have to multiply 4x squared by 1, obviously, to get 4x squared. And when I do so, I will get 4x squared plus 1. Subtract the polynomials again, and we'll get 6. So this is the remainder. And we're ready for the final answer. So our quotient is 2x plus 1. And the remainder is 6. All right, question B. Hence, find the exact value of the integral. Sure, so first, straight away, let's rewrite it as the sum of the integral of the quotient, which was 2x plus 1, dx plus the integral from 0 to 1 over 2 of the remainder, which was 6 over 4x squared plus 1. Of course, dx. Now, the first integral is going to be easy. That's just the power rule. Increase the power by 1, divide by the new power. Simplify the 2's, and we got x squared plus x. And the next one is a bit more difficult. So if you look at the formula sheet, you'll have the integral of 1 over x squared plus a squared, which looks the closest to our case. And that integral equals to 1 over a times the inverse tangent of x over a. So now our goal is to rewrite this integral, the second one, to make it look as close as possible to 1 over x squared plus a squared. All right, to do so, first I will bring 6 outside of the integration to get 1 over 4x squared plus 1 dx. Now, if we're looking at the standard integral, there should be just x squared and not 4x squared. So that means I will take 4 from the denominator outside, and I will get 1 over x squared plus 1 over 4 dx. Now, again, in our standard integral, there's a squared. So I have to write 1 over 4 as a squared number, which gives us a half squared. 1 over 2 squared dx. And now that looks exactly like the standard integral from the table. So it means it's going to be 6 over 4 times 1 over a, that is 2 over 1, inverse tangent of x over a. So a is 1 over 2, and then 1 over a is going to be 2. So that means we have inverse tangent of 2x. Now let's simplify. 6 times 2 is 12, divided by 4 is 3. 3 times inverse tangent of 2x. Okay, and now let's put everything back together. All in all, we've got x squared plus x plus 3 inverse tangent of 2x. And our limits are from 0 to 1 over 2. Now let's substitute the top number. We got 1 over 4 plus 1 over 2 plus 3 inverse tangent of 1 minus, if I substitute the lower limit, I got 0. Now simplify all of this together, and we got 3 over 4 plus 3 pi over 4. You can actually leave it as it is, or you can be a bit more fancy and take out 3 over 4 to get 3 over 4 times 1 plus pi over 4. I will leave this as the answer. Okay, the next question is about differential equations and variable separation. I've actually have one more video dedicated to this topic, so if you're not sure where to start, just have a look, and I'm going to proceed with the variable separation. First of all, I will multiply both sides by dx, and I'll get x plus 1 times 3x plus 1 dy equals to y dx. And now the whole purpose of variable separation is to get x and dx on one side and then y and dy on the other side. So that means first I will divide both sides by x plus 1 and 3x plus 1. I will get dy equals to y dx over x plus 1 times 3x plus 1. Now I get y and dx on the right side. That's not good. So I'm going to divide both sides by y. I'll get dy over y equals to dx over x plus 1 times 3x plus 1. Now on the left side we have a standard easy integral, when I integrate both sides of course, that equals to natural log y. Now the right side is a bit more complicated. We have a fraction, and for integrating fractions we have a nice technique called partial fractions. So I will have to separate 1 over x plus 1 and 3x plus 1 into partial fractions. And both factors in the denominator are linear, so that means our partial fractions are going to look like a over x plus 1 plus b over 3x plus 1. Now combine them together. Again, use the common denominator. So we're multiplying a by 3x plus 1. And we're multiplying b by x plus 1. Now, our goal is to determine the numbers a and b. Now, focus only on the numerator. Basically, on the left we have 1, and on the right we have a times 3x plus 1 plus b times x plus 1. Now, we can substitute any convenient number for x in order to determine those a and b. I will start by substituting x equals to minus 1, because I got b times x plus 1. So if I substitute minus 1, the coefficient of b will be 0. So that's a good choice. Okay, minus 3 plus 1 is going to be minus 2, and then plus 0b. So it means a equals to minus a half. Now I'm going to substitute x equals to minus a third, so I can get rid of a. I will get 1 equals to b times minus a third plus 1, it's going to be 2/3. So therefore, b equals to 3 over 2. And all in all, our integral splits into integral of minus a half 1 over x plus 1 dx plus 3 over 2 integral 1 over 3x plus 1 dx. Okay, now time to integrate. We got minus 1 over 2 natural log x plus 1 plus 3 over 2 natural log 3x plus 1. And then to compensate for the chain rule, don't forget to divide by the number next to x, which is 3 in this case. So altogether, we have minus a half natural log x plus 1 plus 1 over 2 natural log 3x plus 1. And if you factorize 1 over 2, you'll have the difference of two natural logs. So that means you can write it as 1 over 2 times 3x plus 1 over x plus 1. And then we can bring 1 over 2 as the power. So we'll get natural log of 3x plus 1 over x plus 1 to the power of 1 over 2, which is the square root. Now, back to our equation. When we integrated the left side of the equation, we got natural log y. When we integrated the right side, we've got something a bit more complicated. And then don't forget, after taking the indefinite integral, add the constant c. Now, at this point, our goal is to determine the value of c. And to do so, we can substitute the point which lies on this curve. Now, it is given that y equals to 1 when x is 1, so substitute 1, 1. That means log 1 equals to natural log square root of 3 plus 1 is 4, over 2 plus c. Log 1 is 0. Here we got log square root of 2 plus c. Therefore, c equals to negative log square root of 2. All in all, our equation looks like log y equals to natural log square root of 3x plus 1 over x plus 1 minus natural log square root of 2. Now again, on the right side, we have a difference of two logs. That means we can divide whatever is under the natural log. Now, because I'm dividing, this square root of 2 will go at the bottom of the fraction. Okay, now we have log a equals to log b. That means whatever is under the natural log sign must be equal to each other. That brings us to y equals to a square root of 3x plus 1 over 2x plus 2. But even that is not our final answer. We're supposed to find the exact value of y when x equals to 3. So we're looking for y of 3. That is 9 plus 1 over 6 plus 2. We take the square root, and we get square root of 10 over 8. Let's simplify it, and we get 5 over 4. Take the square root. Time to give the answer. Right, so we had to solve the differential equation. Let's state our solution. Y equals to square root of 3x plus 1 over 2x plus 2. And then we had to find y of 3, which is the square root of 5 over 4. That's it. Okay, next question is about vectors. And first of all, I'll just write OA as the vector in a parametric form. So it's 2, 1, 1. And then the vector OB is going to be 1, minus 2, and 2. And first we're looking for the vector equation of the line through A and B. So this line has equation. First, we need the position vector of any point on this line. Let's say A. Plus some parameter, we call it, let's say, lambda, multiplied by a directional vector on the line, which is any vector on that line. Let's say it's vector AB. Now we already have OA, and all we have to find is AB, which is going to be OB minus OA. So it's 1 minus 2, 2, minus 2, 1, 1, which is minus 1, minus 3, and 1. Okay, we are ready to state the answer. R equals 2, 1, 1 plus lambda minus 1 minus 3 and 1. You can leave it in this form, which I actually prefer myself, but you can also write it as R equals to 2i plus j plus k plus lambda minus I minus 3j and plus k. All right, next question is about vectors between the directions of two lines. So that means we'll have to find the angle between two directional vectors of the lines. So first, the line AB has directional vector, of course, AB, which is minus 1, minus 3, and 1. And the line L has a direction vector. It is here, 1, minus 3, and minus 2. Okay, and to find its angle, we're going to use the dot product, which states that A dot B is magnitude of A times the magnitude of B times cosine of the angle in between those vectors. And we can calculate this dot product using coordinates. And the formula is x times x plus y times y plus z times z. So we're going to do this, minus 1 minus 3 times 1, 1 dot 1 minus 3 minus 2. X times x is minus 1, y times 1, y is 9, z times z is minus 2. So all in all, we got 6. Now, time to calculate the magnitude. The magnitude of A, let's say it's AB. And L is going to be B. I'm going to use Pythagoras, so it's x squared plus y squared plus z squared. Take the square root, and I got 11, square root of 11. Now the magnitude of the second vector is going to be 1 plus 9 plus 4. Take the square root. And it's square root of 14. Now let's put everything together. So the dot product equals to 6. That equals to square root of 11 times square root of 14 times cosine of the angle in between. Now from here we can easily find the angle. It's going to be the inverse cosine of 6 over square root of 11 times 14, which is 61.1. Okay, for the next part of the question, we have to show that the two lines do not intersect. I will quickly state the equation of both lines. So the line AB, such as R, equals to 2, 1, 1, then plus lambda, minus 1, minus 3, and 1. And the line L, such as R, equals to 1, 2, negative 3, plus mu, 1, minus 3, minus 2. Right, so first of all, let's assume that the two lines intersect. And therefore, the point of intersection would be when the x-coordinates are equal, when y-coordinates are equal, and z-coordinates are equal. So first, x-coordinates. 2 minus lambda from the line AB should be equal to 1 plus mu from the line L. And the same applies for y-coordinates. 1 minus 3 lambda must be equal to 2 minus 3 mu, and 1 plus lambda for z-coordinates should be equal to minus 3 minus 2 mu. So those are simultaneous equations, and we're supposed to find mu and lambda. Let's do that. Okay, I will move lambda and mu to the left side of each equation, and I will get lambda plus mu equals to minus 1, then 3 lambda minus 3 mu equals to minus 1, and lambda plus 2 mu equals to minus 4. Okay, and I will call the first equation 1, the second one is 2, and the third one is logically 3. Right, so my first move is going to be subtract the first equation from the third one. I will get mu equals to negative 3. Okay, and then I will substitute this into the first equation. I will get lambda, take away 3 equals to minus 1, so lambda equals to 2. Okay, it looks like that we found lambda and mu, but the thing is that we had 2 unknown values and 3 equations. Now, what are we supposed to do with those mu and lambda? We need to check that those values satisfy the remaining equation. So I will put them into 2. Three times 2 minus 3 times minus 3 should be equal to minus 1. And then on the left side, we got 6 plus 9, and apparently it's not equal to minus 1. So what it means is that lines do not intersect, because all 3 equations are never satisfied at the same time. And I will write this as the conclusion. That's it for this question. Okay, and in the last question, we have to find the x-coordinate of M, which is the maximum point on a curve, which means that y derivative at this point equals to 0. So first, let's find y derivative using the product rule. Y derivative equals to cosine x times cosine 2x minus 2 sine 2x times sine x, and that must be equal to 0. Now, I'm going to use the double angle formula for cosine 2x and sine 2x. And we'll get cosine x times cosine squared x minus sine squared x minus 2 times 2 sine x cosine x, again sine x, equals to 0. Now expand the brackets and we'll get cosine cubed x minus sine squared x cosine x minus 4 sine squared x cosine x equals to 0. Factor out cosine x. And we get this equation. Now, the product of two things equal to 0, so that means either cosine x equals to 0, or the bracket equals to 0. Now, for the first equation, we get x equals to inverse cosine of 0, so x equals to pi over 2. And let's have a look at the graph. Pi over 2 is here, so definitely that's not the x-coordinate of m. And let's have a look at this second equation. We get cosine squared x minus 5 sine squared x equals to 0. Let's replace cosine squared with 1 minus sine squared. Simplify it. And let's keep solving it. Take the inverse sine, and we get x equals to 0.421, correct to 3 significant figures. And that's going to be our final answer. For the next question, we'll have to use the substitution to find the shaded area. And first we'll have to find the intersection with x-axis. And that happens when y equals to 0. So that means sine x times cosine 2x equals to 0. And that happens when either sine x equals to 0 or cosine 2x equals to 0. So the first equation gives us x equals to 0, and that is, if you look at the graph, point O. And for the second equation, you get 2x equals to pi over 2, or x equals to pi over 4. So that's our point of intersection. So that means that the area equals to the integral from 0 to pi over 4 of sine x cosine 2x dx. Now it's time to use the substitution. So u equals to, as the question suggests, cosine x. And then we'll have to rewrite this integral in terms of u. I will start with finding dx in terms of du. I will first differentiate u in terms of x. So du over dx equals to minus sine x multiplied by dx, and we get du equals to minus sine x dx. And then for dx equals to minus du over sine x. And our original integral is going to be equal to sine x cosine 2x. And then instead of dx, we have du over sine x, and don't forget the minus sine. Now, sine x and sine x will cancel out. And I will get the integral cosine 2x du. I will use the double angle formula. And get 2 cosine squared x minus 1 du. Now, using the substitution, we'll get 2 u squared minus 1 du. And now let's recalculate the limits. If x equals to 0, then u equals to, we know it's cosine x, which is 1. And next, if x equals to pi over 4, then u equals to square root of 2 over 2. So all in all, our integral is going to be from 1 to square root of 2 over 2. Now let's integrate and get minus 2u cubed over 3 minus u. And the limits are from 1 to square root of 2 over 2. And now it's time to substitute the limits. Minus will be in front. Okay, so simplify that and we get minus 1 minus square root of 2 over 3. And we can write it as square root of 2 minus 1 over 3. And that will be my final answer for this question. Okay, so that's it for this paper. I hope it was helpful and I will see you next time. Bye!